Welcome back to another workshop. We are now joined by Mr. Stiles. Welcome
Hello.
along. Now, many of you will know that there's been a really strong building of the Automatics A12 team, so we thought a really good opportunity to be run through the chassis, which is very different. So give us some insight into what's so different about the chassis.
Yeah, as you mentioned, Stu, it's this is obviously a new car, and it's a very different, unorthodox design compared to what you've typically seen over the last 10 years or so in 112 scale. So what I'll do is basically run through the car, top to bottom, front to back, to try and explain a little bit about how it works, and then I'll run through a few things that we do, not only when we're building the car, but option parts that we fit to it as standard, just to make it a bit better suited to our tracks and the kind of racing that we do. So it's probably easier if we start underneath here. So if we look under the bottom of the car, whereas previously you may have been used to seeing a main chassis plate that the front suspension and the battery and all the electronics are mounted to, and then a separate pod at the back of the car with a ball and socket pivot, side links, with essentially a live rear axle. This is a bit different in that we've actually got what we call an inner and an outer chassis. So the inner chassis, the black one here, or the battery tray.
So if we just hold it up to the camera in front
as you can
of
you can see underneath. So this black coloured chassis is the battery tray. And it's onto this that the battery sits, but also all of the electronics and the front suspension as well. So then essentially what people are used to seeing as a pod on the back is actually an outer chassis that runs the whole length of the car. So the motor and the axle and the rear pod assembly is all connected to this chassis here. And rather than a pivot at the back of the car on the centre line, we've actually got two pivots that are at the front of the car, here and here. So for those of you watching this that have been around 12 scale for a long time, like some of us have, will remember the days when we had sub-C batteries mounted on either side of the car with a fiberglass T-bar running down the centre to control the roll and the bump at the back of the car. This is similar to that in how it works, except the two pivots that were previously at the back here for a T-bar are now at the front of the car.
Okay.
That doesn't really matter mechanically because it's the two pivots trace a line between the two of them. All we've done is shifted that to the front of the car, and then we've got to connect that obviously to the back, which is where these long side rails come from. So with a T-bar, when you induce roll into the car, it would have twisted the T-bar, which this doesn't do. This is still relying on side springs for your roll stiffness, rather than the springiness in a fiberglass T-bar. But in bump, it behaves very, very similarly to how a T-bar used to, in that we're basically relying on the flex in these side rails to control the bump of the car.
Okay.
That's the premise of how the car works. It's very, very unusual, but actually once you get your head around it, it kind of makes sense. The beauty of it is actually it's quite simple. A lot of people look at it, and because they're not familiar or not that au fait with what they're seeing, they think, oh, that's too complicated, I don't understand that, I'm not going to run it. But actually, you've just got to think of it as being different, but not necessarily more complicated.
Sure.
And in many ways, it's simpler than a standard link car with a dynamic strut front suspension. In terms of what the car comes with, you'll open the kit box and your immediate reaction will be, oh my god, I've paid all this money and is that all I get? Because it really is a couple of chassis, some carbon plates and some nuts and bolts and screws. So on the face of it, it looks like you're not getting that much for your money, but actually every single part in the car is really, really high quality. It all fits together beautifully. You don't need to fettle or sand anything. So literally, like a lot of the cars are these days, you know, it's very much just assemble it and it's going to be there or thereabouts. In terms of what we fit to the car as standard, the car comes with what what we call a minus 1.5 front suspension plate. So if you see the front of the car here, this main carbon plate at the front here is basically what the steering and all the front suspension mounts to, and you can get different versions of this plate to move the kingpins backwards a different amount to change the wheelbase of the car.
And what does that do from a driving perspective?
So generally, if you shorten the wheelbase of a car, it's going to make it more nimble, more agile, it'll turn harder, be less stable. So, you know, if you're someone who likes a very predictable, easy car, then it's probably not a good idea to go maximum short on the wheelbase. So when the car was initially released, it came with what we would call a 0 front suspension plate. But now, if you go and buy a kit now, it will come as standard with a minus 1.5.
Okay.
So they've actually gone
Shorter as stock.
ever so slightly shorter
yeah.
for stock, because they basically realised the car was a little bit too long and it just dulled it down too much. So we think that having a minus 1.5 arm is basically going to be in the right ballpark for the majority of drivers.
Okay. And that came about from the practice that you'd done over here or in the US?
It was actually before my time running for Automatic. So this car was initially released about a year and a half ago, and it was kind of last summer, autumn time that the kind of initial group of drivers that started testing and developing the car off the back of the IFMAR Worlds in 2020, they kind of started to move towards thinking that they needed to sharpen the car up, make it a bit more aggressive and turn harder, so which is what led them down the short wheelbase route.
So we've had a few questions come in by the looks of things, Mark, and we welcome them, guys and girls out there. So Matt Jones says, so can the same kit be used for GT12? Excuse me, that is a different stream. They're questions for Dave Spashit's car. I just bought an A12, looking forward to this. Slapped it on the track already, it was fantastic. Chris Lemon, main question for all the chats, what changes do you make to compensate, if any, the switching between low and high grip carpet on surface? Yes, high grip.
So there was a question at the top there that is asking a question that's relevant to this car.
Okay,
There's
great.
a few people that have asked whether you can use this car for GT12 with UK rules. Unfortunately, the answer to that question is no, because the UK GT12 rules state that the main chassis has to extend beyond the rear axle centre line, which, if you look at the bottom of the car, the main chassis stops here. So the chassis is too short, basically. And also, it could possibly be argued that we've actually got a two-piece chassis here.
Yes, of course.
So it's a little bit of a grey area in terms of defining what the chassis is and what the pod is.
Right.
Because it's a different design, but actually the slam dunk from a UK GT12 rules perspective is the fact that the chassis is not long enough and it doesn't extend far enough. So that kind of shuts the conversation down.
Right. And the going on to what Chris Lemon said about changing from low to high grip.
Okay.
What areas do you?
So a lot of people have found that when they build the car it's standard out the kit, they put it on the track. It's really consistent. It's easy to drive. It's nice. But what I would say about what comes in the kit, one of the key kind of tuning aids and performance differentiators in the car is this damper at the rear.
Okay.
So this is like a damper unit. It's got straws inside it. I've got one here. I can show you basically how it works. So whereas you might be used to on a conventional car, straw dampers at the side that are kind of telescopic, the rod slides in and out of a tube. This is the same principle. It's a rod in a tube, but rather than slide in and out, it rotates. So it's got these little arms.
Yeah.
Works. It's basically the same design. It just works in a slightly different way. But this is quite a key and sensitive tuning aid to the car. In the standard kit, you get supplied with 100k silicone oil to put in this damper, which we found running on UK tracks in the kind of grip that we have, the tyres we use, that's a little bit stiff. 100k is a bit much. However, what 100k will do is it will lock the car in and slow everything down.
Yep.
So if you're throwing the car into a corner, if the car's over damps at the rear, it will just slow that weight transfer down, and it will make it feel like the rear is very locked in and safe and planted. So we have found that going lighter on the fluid in this rear damper is generally better for when the grip comes up and you want the car to sharpen up a bit, because you have enough grip in the track to mean that the tyres can hang on. So if you're turning the car harder and quicker with lighter damping, you've got enough grip for the car not to step out and do funny stuff. So I would say in lower kind of club level grip or on carpets that generally have lower grip or traction, you want to be running heavier fluid in this rear damper. As the grip comes up, go lighter and lighter, and it will make the car turn harder, but also it kind of comes alive and it feels like you're driving something a bit more pointy and racy.
Do you change much with the spring wise on the sides when you
Not really.
They stay stuck with pretty much one spring.
These are the kit springs, 0.5 springs, which we've generally just stuck with. I think there's a 0.4 which is a bit softer, and they're actually, I think, the only two side spring options that you've got. They are much softer than side springs that you might get on other cars, but one thing that's important to remember with this car is that all the weight is along the centre line of the car, so that it's an inline battery rather than transverse. All the electronics are very slimmed down, the servo's out the front, so if you look at how the weight is distributed in the car, it's all very much towards the centre rather than being out wide and short. So because of that, when the car rolls, you're not transferring as much weight from one side of the car to the other, which means that you can get away with running a softer spring or less roll stiffness. So that's really why the side springs on this car are much softer than you'd find on a lot of other cars, because of the way the weight's distributed in it. The same thing goes for the front suspension. Generally, we're running front springs that are quite a bit softer than what, I don't know, an associated 20 thou or a Xenon 0.5 spring. We're quite a bit softer than that, again, because we're not transferring as much weight from side to side.
That's quite interesting difference between the other guys when they're talking about they're trying to make things stiffer because they're a bit wider, a bit more roll moment. You guys are not having the same situation because it's more narrow.
Yeah, I mean, having the weight distributed like this does have its limitations and drawbacks. So, but
that's the same with anything, though, right? I mean, you go one direction, you're going to plus and minuses.
We're limiting the lateral weight transfer in the car, but actually having it all along the centre line means that you're transferring more front to back. So, because of that, you might find you end up running different droop settings on the front and rear to try and limit that weight transfer. Generally, we're running less droop on the back of this car than what you would on a normal car.
How much are you running?
I'll get to that in a minute in terms of how we measure it. You measure it in the same way as a conventional car, but the way we set it on this car is different to how you might do it on a conventional car. That's basically to answer the question. When the grip comes up, go lighter in your damper, and it should just sharpen it up a bit. Just while we're on the subject of springs, with the side springs, there's two positions you can run it. So on the inner position, it will give you a spring rate, a roll stiffness. If you move it from that position to the outer position with the same spring, it will give you a 50% increase in roll stiffness.
Right.
So essentially, if you're running a 0.5 spring on the inner position, if you move that to the outer position, that essentially makes it what a 0.75 would be on the inner location. So if you're looking for a stiffer side spring, but maybe a small change, you could think to move it to the outer hole. Interesting to note is that the side springs as well, I think they're the same size, certainly the diameter, they're the same as an X-ray side spring. So I think there's a bit more range in the X-ray side spring choice. So if you want to go stiffer, maybe consider you going to an X-ray 0.7 or whatever.
So we've covered the rear of the car. So moving to the front of it, you said about the shorter and the longer options. You've got quite an interesting camber change. Kingpin set up, haven't you?
So at the front of the car, like I mentioned before, we've got this plate as standard now, it comes as a minus 1.5. You can also get a -3 and a -6 plate as well. But you've also got to be mindful of what axles you're running.
Okay.
So as standard, the car comes with a minus 1.5 plate and trailing axles on the front.
Gotcha.
So axle trail, for those of you that don't know, if this is the kingpin, the axle sits about 3mm behind the kingpin. Just means that the car will track straighter. Generally it will make it a little bit less responsive going in, but it should pick up steering in the middle of the corner with trailing axles. You can get inline axles, which put the axle in line with the kingpin. That will make it respond very quickly, but you might find that the car washes a bit more in the middle of a corner. So if you've got a lot of fast direction changes on a track, you might want to consider inline axles rather than trailing. Whereas if you've got more sweeping, fast flowing bends, generally trailing might be a better choice. But it's really, it can be driver specific as well as track specific. So we've got guys here today, some of them are running trailing, some of them are running inline, depending on what they like. So yeah, as standard, comes with a minus 1.5 and trailing. I would say you probably don't want to run like -4.5 or -6 with a trailing axle, because that will make the car really short. The idea of the -6 plate is to take account of the fact that if you run an inline axle, it moves the axle forward on the car. So generally we'd run a -4.5 or a -6 with an inline axle to bring it back to the kind of wheelbase you get as standard.
So you've got some nice variability there with
there's lots of adjustment
with
with the length of the car,
which is a real polar opposite to kind of David's car that was just bringing there. It's certainly appealing to two different types of markets, but I think the difference being is that these cars are so nice to drive now out the kit on the track, sweet from the start.
Absolutely,
but again, you guys are offering more and more options to change and tweak and play around.
This car is out the box, you build it as standard, it goes round a dream.
Absolutely.
I ran kit setup apart from a front spring at a Tamworth club meeting, and I was racing around with Matt Barrow and Ollie Payne quite happily. So you're going to have a competitive package out of the box, but if you're somebody who likes to fiddle a bit and tune, there are lots of options and things you can do. So it's for some people, but not others.
For sure, and it's having a nice range of variables if you want to go deep in buying hop-up bits or not.
Absolutely, yeah. I mean, what I've actually got is two different front ends.
Right.
So because I'm a little bit on the fence as to whether I prefer trailing axles or inline. So I've built two front ends, one with trailing, one with inline. So then I can just do a back-to-back test, and it's 4 screws to change this. Plug the servo in, and away you go. So a lot of people, will buy 2 cars and have 2 cars on their pit table, whereas I've never been a fan of that, because then you've got to pick one of them. Whereas I've got 2 front ends, so it's a little bit more focused.
I've got 2 front ends. So what does it look like in the box? Let's have a little look at it.
That's just my box of spares. It's not a kit.
Of course.
You asked about the Camber, the front end. So whilst on a conventional car, you might have a turnbuckle to adjust the camber on a dynamic strut. The camber and caster is all included in the kingpin here. So, as standard in the kit, you get a 4-degree caster post, and then it has little holes around the edge of the post here that are indexed onto the lower arm,
which is really neat.
It is neat,
Really
so
neat.
you basically pick a post according to what caster angle you want. So it's 4 as standard. You can get 5 or 6 degree posts. Generally, we found the 4s are about the best, and we tried 5 and I didn't really like it that much, so I went back to 4. And then the camber, like I say, is indexed, so you can run anywhere between 0.75 of a degree and then go up in 0.25 increments up to, I think it's like 1.5 or 2 degrees or possibly more. We have found though that you want to be running 0.75 and not really any more than that camber wise, because the car doesn't roll very much. Again, because the weight's down the middle, there's not much weight transfer, so it's not rolling a great deal. So it doesn't roll onto the tyre. So we're finding that we're running less and less camber to get the tyres to wear flat. I would say your standard setting should be the kit 4-degree caster post and set it to 0.75 on the indexed hole.
Interesting.
But it's nice. It's a nice thing to have because it means you haven't got to get a set of gauges out to set the camber. You can just move it to a hole,
Done.
tighten it up, and there it
Good
is.
to
And
go.
you know it's going to be exactly the same both sides, and you haven't got to keep chasing it.
Yeah. And
So
it
that's
seems
quite
like
nice.
X-Ray have gone that way, haven't they? They've gone, kingpin with a set
Yeah.
camber, which is interesting.
Yeah.
Chris,
I think a lot of the previously the front ends on 12 scale cars were quite complicated. There's lots of turnbuckles and things to adjust, whereas now manufacturers seem to be going to more what I would call an indexed or a kind of slotted design, so that you basically build it and slot something in or put a pin in to set what you want to run, because otherwise you can just chase your tail with camber, caster, toe, and just keep chasing yourself around the front end.
and then end up back where you started.
Exactly, yeah.
Which
Happens to the best of us.
which we've
Yeah.
said so many times before.
With the front end as well, we've got the steering block here, which as standard the kit will tell you to build this block with some O-rings inside it. We build it without O-rings, so just fit the little plastic inserts and screw the cap on. What we do run is some grease, so we smear some grease on the kingpin before we screw the caps on. We found grease to be better than silicone oil because grease is a bit more viscous and it doesn't get everywhere.
Yeah.
So what we've been using is this Kyosho Diff gear grease. This is 15,000. You can get 10,000 and 5,000 as well, but 15k is about the right place to start. Literally just smear it on the kingpin and slide it in, do the caps up, and this is butter smooth when it's built on the car. It's really nice. Just gives the front end a little bit of damping and takes the pogo stick effect away. So when you come to build this on the car, principally it's quite simple. It's a block sliding up and down a pin, but it's quite detailed and a little bit finicky in terms of how you put it together. So your ride height on the front of the car is based on how you shim this block on this kingpin.
Okay.
So I'll run you through quickly how we build this front corner as standard, because if you get to that point, then it's very easy to adjust ride height without affecting any other aspects of the setup. So once you've got your kingpin sleeve on your block like this, we use 6 0.2mm shims, and these are basically what you use to adjust the ride height on the car.
Okay.
So as standard for a fairly large tyre, you want all of the shims on the bottom of the block to lift the block up relative to the car, to lower the front of the chassis. So I've got 6 0.2mm shims here, which you get in the kit. You slide those over this sleeve. They just sit on there like that. And then when you come to assemble it, just make sure that you slide the sleeve over the pin and push it all the way down to the bottom before you press the block down, like that.
Gotcha.
So then the block sits down on top of the shims and the shims don't get caught underneath the sleeve.
Right. Yeah.
So it's very important to make sure you...
Or else the shims are just going to fall out the bottom.
Exactly, yeah. So just make sure you slide the sleeve down before you push the block down onto the bottom. When you've got it like that, take your spring. We run C 1.1 springs, which are a bit softer than the kit ones. They go on there like that. Then what we do, I mentioned just now that we run 6 shims here. That's more shims than the kit tells you to run. Because what we also do is run a small spacer on the top of the kingpin. So basically what it does is it makes the kingpin longer to give you more ride height adjustment and more range for adjusting droop and ride height. So because we've added a shim, this is 1mm, this shim, we've added that to the top of the kingpin, so we've had to add shims to the bottom to make up the length. So with a C 1.1 spring, we've got a 1mm shim on the top of the kingpin and 6 shims under the block. I'll put that on there. And then, as standard, you've just got a button head screw and a washer, but we found some neat little washer and screws combined. So this is just an M3 button head screw, but with a bigger head, so you don't need a washer behind it. These are made by RDRP, I think.
Yeah, that's it. Yep. Got some of
I
those
think they're
myself.
made for touring car or electric buggy wings.
Yeah. Yeah.
So they're quite
They're
neat
very
because
neat, aren't they? Yeah.
the head is just the right size to fit over spring.
Spring,
So and that goes on the top there, threads into the top of the kingpin. And then just take your driver and tighten it up.
And how long do you put that in the oven for?
Gas mark 6, 30 minutes. So yeah, with a 1.1 spring, we've got our 6 shims and our 1mm spacer on the top.
Yep.
Having all the shims on the bottom here, that gives you basically your max ride height. So this is for when you're running a big tyre.
Yep.
So I found with this setup, I can run about a 42mm front tyre and get about 3.5mm ride height.
Yeah, that's great.
If you want to run a smaller tyre, obviously then you'll lose ride height.
Yep.
So to get that back, all you do is take shims out from underneath the block and put them on top.
Yep.
And you can go in 0.2 increments, or if you want to run 0.1mm thickness shims, you can have 0.1mm incremental adjustment on your ride height, but 0.2 is ample really. So that's, once you've built it, if you then run a different tyre and you want to change the ride height, it's quite simple, just move shims from the bottom of the block to the top.
Yep.
You don't have to take any out or put any in.
Yep.
Once
Just
you've
move
built
around.
it like that,
You're just
and
moving the block up and down.
yeah.
Yep.
The only time you ever want to add shims or take them away from this assembly is if you want to adjust the droop.
Yeah.
So this build I've got here will give you, with this spring, about 0.2, 0.3 of a mil of front droop, which is in the ballpark for what you want to run.
Good. Well, Mark, that's been a great overview of the car. And your expectations this weekend? I mean, you've been practicing a lot. Keep
Well,
it short because we've got 1 minute left.
I am known as Mark Stiles the third.
Okay,
so
well, yeah.
If I can do
But-
better than
yeah,
third, I'll be
okay,
happy.
okay. Well, listen, we wish you luck and thank you so much for your time.
No problem.
It's been super insightful. If you've liked the video, hit the like button, share and subscribe with your friends. And stay tuned, there's got some on-track workshops coming your way this afternoon. Mark's going to host one of them. So stay tuned and we'll see you all again very soon.
Ciao for now.
Welcome back, everyone. We are with the world famous Mr. Hagberg, and this evening we are going to talk about driving technique, which I think is something that we don't often get to talk about. We go out, we drive our car, we try and get faster, we think it's all in the car, we partly take responsibility for the driving, but of course nobody really teaches us. There's no workshops. I mean, you see the odd workshop in buggy racing, funnily enough, but actually you don't see any of it in 12 scale.
Yes, and I find this very interesting because when you raised the idea to have a driving technique workshop, it made me think about it a lot, which more than I normally do. I mean, I always try to think about my driving technique, but it is something that's really difficult to technically explain what you're doing, because the driving you do by muscle memory. You do it from your instinct.
Yeah.
You don't really think about, oh, I'm gonna turn the wheel at this amount of angle at the end of the straightaway. You simply just do it, and that's the problem. Even for us top guys, we don't reflect too much on what we're doing. Sometimes we have to, because that's the only way we can really improve. So I will try my best to explain, even though it's difficult even for me to give a technical explanation.
And of course you've got this I mean, you're a wheel guy, and of course there are old schoolers that are sticks.
Yeah.
That in itself is a whole area, isn't it, before we even start talking about.
That's a big difference, and I think a lot of people forget that sticks versus wheel requires a very different radius setting. For example, normally you have to use more steering expo with the sticks compared to what you have to use with a wheel. And the brake setting is largely different as well. I think with the wheel radio you have to use less of a brake EPA, basically a weaker brake, whereas I see most guys with the sticks, they use a stronger brake because they're able to control it better with a stick. I think the steering is more sensitive on a wheel, but the throttle and brake is more sensitive on the stick radio. There's pros and cons to both types of radios.
That's an interesting area.
But let's talk a little bit about the driving technique for 12 scale, because it's changed a lot over the years. When I started with 12 scale 15 years ago or more, it was very different. We used ball diffs in the rear, the car were not as powerful. We used harder tires, bigger tires.
Did you say hotter tires?
Harder.
Harder, sorry.
So harder tire compounds, taller tires. The cars handle very differently. Today the cars are insanely fast. They're always on the edge. It's almost like a computer game, is what it feels like sometimes. So, especially since the introduction of solid axles, the driving styles have changed, and it's been necessary to change our driving styles. And when you have a solid axle in the car, basically you have to be more cautious to how you apply the throttle, because you use, more than ever, you use the throttle to steer the car coming out of the corner, depending on how much throttle and steering you apply at the same time. And the most difficult part is in open modified, for example, to know when to really get on the throttle. Because you need to wait for the car to finish rotating through the corner. Basically you need to wait till both tires are on the ground before you apply full throttle. If one tire is in the air, the car will try to spin out or do weird stuff. So it's really difficult to find the limit to where you can really push out of the corner. And that's the most difficult change, going from a rear differential to the solid axle. Obviously we can adjust the setup to make it more forgiving and to make it easier for us to adapt. But this is a big difference since we took away the differentials. The lower roll centers in the cars have helped a lot for this as well. But another thing which I wanted to talk about and I wanted to demonstrate on the track, maybe later when we get a chance, is how to use the brakes. Because in the stock classes, we don't need to use a lot of brakes, if any. I mean, it depends on the driving style, but ideally you don't use a lot of brakes in the stock. But in open modified, it's absolutely necessary, and I'm going to explain why. It's necessary not only to slow down the car for the corner, but to help the car transfer weight from the rear to the front axle on corner entry, so that the car gets on its nose and it helps the car to make the corner. I wanted to demonstrate driving a lap using no brakes versus using brakes in basically every corner, which you have to on this track. Because if you don't use the brakes, you have to lift so early to make the car slow down naturally, And not only you have to lift a lot, but if you don't brake, the car will be flat, right? It will not be on the nose. It will be basically static, and it will not have as much front grip of power going into the turn. So I use the brakes to slow the car down, but to help shift the weight to the front axle and corner entry. Very important in modified because you have so much power, and the car cannot make the corner by itself coming from that high speed. In stock, it's very different. You need to maintain the speed because you don't have a lot of power. So you need to make use of the power of the motor. Basically, the goal is to be on the power as much as possible. And you want to lift as late as possible and kind of swing the car around and get on the throttle again. Whereas in modified, it's very different. You could say that in modified, we drive more from point to point, if that makes sense. It's not a beautiful driving style. It looks kind of choppy, let's say. But that's often when you're going the fastest. You come into the corner, you brake, you make the corner, and you accelerate out of the corner. Whereas in stock, it favors a more efficient driving style. So a more beautiful driving style, so to speak. You can take David Spashett, for example. He has a perfect driving style for stock because he's super efficient. He doesn't lose much speed going around the corner. And that's the goal in stock. That's the difficult part in stock, that you need to drive more of a perfect driving line than in modified. I think in modified you can get away with being less precise, where in stock you need to be perfectly precise to carry the perfect amount of speed. So on the occasions where I've driven stock, I struggled sometimes because it was hard for me to adapt to drive the perfect line, and not being able to use the throttle as much to steer the car as in modified. So I actually found myself crashing more in stock than in modified, which sounds kind of crazy, but that was the reality, because you try to find the limit with the perfect driving line more than in modified. That's what I feel. And that's the big difference between the two classes. I don't drive much stock anymore, rarely, but I understand the difference, and I respect the difficulty in maintaining this. So yeah, those are the most important things I wanted to discuss.
And so this weekend, it's the first time I've really applied myself in modified. So 3.5 open. I mean, there's a plethora of setups that you need to be aware of with the Speedo, and of course that in itself, drag brake, the amount of brake is obviously balancing the rear grip of the tyre, isn't it? Because you have not enough drag brake, you'll want to use too much brake, and then you have too much drag brake, and it will break traction as well. So you've got to find that blend, haven't you, of being able to push the car, find actually where you lift off and the drag brake comes in and then transfers it and slows it. When you're setting the car up, do you have this opportunity where you can almost compartmentalize that's car setup and that's ESC setup?
Yes, it's sometimes difficult to separate the two. Like, you're trying to understand where your handling problems are coming from. Is it from the bottom end being too aggressive? Is it from the drag brake being too weak? It can be difficult to pinpoint sometimes, but I try to pay a lot of attention to it because, as you said, the relation between push brake and drag brake is absolutely critical in open modified. And it is necessary to use the drag brake to go fast in open modified. But yeah, I fine-tune it in percentage of 1%.
Right.
Sometimes to achieve the perfect balance.
Yeah. And do you find you do that during, like today on a practice day, you're just sort of a couple of percent, 1% off?
Yes.
You're doing that all of the time, pretty much. And so you turn up at a venue where you roughly know the grip, roughly know the tyre, roughly know the setup, and then you branch out from there. Yeah,
exactly. So I try to start with a basic ESC setting that I know worked at a similar track or a similar size track, and I fine-tune it from there. I also fine-tune the brake EPA on the radio. So usually on the Sanwa M17, I use around 70% of brake percentage, and I can go up 3 or 4% if necessary, or I can go down 3 or 4%. depending on the track grip. Obviously, the more grip you have, the faster the car will slow down when you brake. That normally means that you need to reduce the brake EPA to be more efficient and to carry more speed. So yeah, those are things that I play with in between runs.
And of course, all of the insights that we get from fantastic guys like yourself that share this data and info, of course, we're getting it. This is where I ended up. Now, of course, I actually copied your ESC settings. I can't remember where it was from, but I got it off of your Facebook page, your race car Facebook page, and I applied them. And of course, that was at the end of the weekend, right? Whereas, of course, if I've turned up with that, with low grip, set up not quite right on my car, of course, it might not be applicable. But of course, you can't keep a running log of where you started and where you finished.
Right.
People need to appreciate that, don't they? That this racing, this carpet racing, even outside, of course, is ever evolving, and it's knowing how all these cogs are moving and where they fit in your mind. And so when you get people come up to you at a race meeting and say, "Where's your ESC setting?" you can tell them, but of course, there's so much more to it than just an ESC setting, isn't it?
Yeah, exactly. It's a typical question somebody will ask my ESC setting, but it doesn't always mean that that's the right setting for them. Yeah. And sometimes it's not even necessarily the right setting for me in between two cars. Let's say you have two cars, different setups on them, they feel different. This car here might need more drag brake than my other car, and vice versa. And you need to get a feel, you need to get an amount of experience to where you can change this to make the car do what you want. And I've raced for so many years now that I think I have a good feeling for what the car needs to have changed on it to get faster. I mean, the level's so high, sometimes that's not enough, of course. Yeah. But when you have a lot of experience, it's easier to know what to change to go faster. And yes, it's good to ask the pro guys, the sponsor guys, the local fast guys, whoever. It's always good to ask, but in the end, you need to try and learn for yourself as well. You need to learn by doing. Because for example, I'm not an engineer kind of guy. I don't have any schooling in engineering. All the experience and knowledge I have is from things I've learned on the track or from other racers. I haven't read books about how to set up an automobile. But I've raced and practiced so much throughout my career that I have good knowledge on what to change on the car.
Yeah. And when you start to evolve, talking about getting faster, really, we all want a car that feels consistent, pliable. We can drive it aggressively, but there's that point, isn't there, where you talk about traction. The car can become really nice to drive, but actually you've gone over that point where, okay, it's really nice to drive, but unfortunately, it's now going slower because it feels super easy to. So there is that window, isn't it? Like traction. You know, you find that traction window. You go too past it, you're slower. You go under it, you're slower. Yeah. Finding that happy medium, finding that blend. That not just getting a setup that makes you feel like you can just drive around the track. Once you find that, you've then got to find that moment that now pushes you on. How do I find those extra tenths? What would you give? What feedback can you give to people in terms of the balance that you're always monitoring through the front of the car and the rear of the car? Because as we know, too much traction on the rear, the car is over docile, pushy. Too much traction on the front compared to the rear, now it feels hooky, unstable. When it's balanced, now we're in a good place. But of course, it can be balanced but slow. What can we learn from that balanced and being slow point? I'm speaking personally for me because I really want to know.
Well, I got asked this exact question quite recently. A guy messaged me on Facebook and he asked, so my car feels great, but I'm losing time and I don't know why. So, okay, but maybe the problem is that your car feels great. It feels too comfortable to drive. You don't have enough steering. And unfortunately, since we went to solid axles, the setup window has become smaller. It is more difficult to set up the cars now to go really fast. And I've often had cars that didn't feel all that great, but they were fast. So they had a lot of front end. And when you hang on to it, it's really fast. But it's difficult to, with the solid axle, in the current cars we drive with the super soft tires and all these things, it's difficult to have a car that feels really good to drive and it's really fast. Almost impossible, I would say.
Yeah, and you only have to watch people like yourself and the Reinhards and Orlowskis of the world, you know, that are driving these cars exceptionally fast. There are moments where it looks like almost like a juggler that's just about to drop his balls.
Yeah.
You know, it's like, oh, he just gathered that one up. You know, and I certainly get that feeling driving. Not saying that I'm driving at your level, but with the mod car especially, it feels like it's all a little, and it just grabs a bit of traction at the right point, stops hitting the barrier, and then it fires itself forwards. That's not for the faint-hearted, is it? But you can still feel that in a stock class, in any class.
Yeah.
And it's almost like just short of that point,
Yeah.
just the point where it just loses itself and then just grabs itself again. You're almost there, aren't you? And it's being able to deal with that over the 5-minute run, the 8-minute run, or whatever your run time is for that class.
Yeah, exactly. It's almost like you're wrestling with a car. At times you try to keep it on the track, but at the same time go really fast. And unfortunately, it's a result of how the cars are designed today. Solid axle, the really light body shells, the really soft tires, the really small tires. All these things contribute to this place we're in, where it's really difficult to get a good feeling and go fast at the same time.
And you know, we could talk about this for hours, but you know, and if you've got any questions, fire them over. But much has been made now with these programmable servos on the front that are making the changes. I mean, I've just been out there again, and you know, you made a beautiful video about the different ingredients of the SXR, the Samuel servo that you run. How much do you use that? I mean, I find it overwhelmingly enjoyable to just tweak it, knowing what the various ingredients do. Have you been out there using it today? Do you tweak them as you go?
To be honest, in 12 scale, not much.
Interesting.
I haven't played with it much in 12 scale, simply because I don't run 12 scale as much as touring car, and I didn't have time, or I didn't want to dedicate time to test this. I mean, touring car, I play with it a lot, especially outdoors on high-speed tracks where there's a lot of load on the servo, let's say. This makes a very big difference. But I want to play with it in 12 scale in the future, just I haven't had the time yet.
Yeah.
So at the moment I'm just running the standard setting with a bit of negative steering expo, about 8% I think, and that's it.
And if you always run negative expo,
Yes.
8 is as much or as little as you go.
Usually between 5 and 10%.
Okay.
For
And
this class.
you just feel that takes the edge off it.
Yeah.
Yeah.
I think there's no disadvantage of running a bit of expo. It just makes the car a bit more forgiving around neutral. It makes it easier to drive in a straight line, so on. I mean, you can fine-tune the settings while still using steering expo. I think that's the best combination.
Interesting, because I've never used Expo. I've been a zero guy the whole time.
Okay.
And I feel what you're talking about. It really feels like on the edge initially on the stick. So I might give that a go.
Another thing to remember is that the expo only affects the first small percentage of the stick movement, right? So a lot of guys, they prefer to play with, let's say you don't have an adjustable servo. You can adjust the steering speed on the radio, just to slow everything down.
Yeah.
Sometimes that's more effective than the expo because the steering speed works on the whole spectrum of the movement, not only the first percentage. So that's what a lot of guys do in off-road. They change the steering speed instead of just the expo.
Yeah.
But in general, I prefer to use a bit of expo and then fine-tune the setting in the servo.
Yeah. And you know, these topics are huge, aren't they? I mean, we spend so much time on the cars and but the servos, the ESCs, the handsets. I mean, the handsets. I mean, I've done plenty of videos as you have on these handsets. There is just so much to them and so much adjustability. We invariably just plug them in, have a go, and off we go.
Yeah.
There is bits there that are there to help us and get the most out of your performance. How long have you been using Sanwa?
So I've been sponsored by Sanwa only since 1 year. but I've been using Sanwa radios probably for the last 8 years.
Yeah.
M17 came out in 2018, so I've been using it for 4 years now. I try to change the radio every year,
Yeah.
or at least
You change the radio every year.
yeah. There's something you need to pay attention to, and it's very important.
Okay, this sounds like a speed tip coming up here.
When you switch on your radio,
Yeah.
you have a logger that states how many hours the radio's been used for.
Right.
So mine's been used for 71 hours.
Okay.
For servicing, to change the potentiometers of the throttle and the steering,
Right.
because they wear out. And the radio can start doing weird shit. 200 hours, there's a warning sign.
So what you're saying to me, Alex, is that I am not as fast as you because my radio's worn out.
Possibly.
Yeah. So 200 hours.
Yes, I would
Interesting.
say if you drive a lot,
Yeah.
change the radio every year,
Yeah.
or have it sent to Sanwa for replacement of the potentiometers.
Interesting.
A lot of people don't pay attention to this. They
Yeah.
use the radio for years and years.
Yeah. Yeah.
It wears out.
Yeah.
And they struggle, right? And they don't know why. Another thing to do, which is quite important, especially if you travel a lot with the radio, if it gets bounced around a lot, do the calibration. What you do in the system is 100% inside of the radio's software.
Right.
That's what I do with the calibration. I try to do that quite frequently.
Right.
All these things.
These. I mean, these are speed secrets. These are speed secrets, aren't they?
I guess. I mean, it's just good advice for people
Yeah.
in general.
Absolutely. Absolutely. Well, Alex, look, it's been really insightful, and we are going to re-record the X12 23 video of Alex's car. I made a blunder on the screen, so it will be here tomorrow lunchtime, just after a lunch with Andy. So my apologies to yourselves out there, Alex, and the whole of the X-Ray team, for my hiccup. But if you've liked this video, hit the like button, share and subscribe with your friends, and see you all next time. Thanks very much,
All right.
Alex. Good man.
Talk tomorrow.
Stop.